Okay, so now let's take a look at a mixture problem. And what we have here is we're going to look at a mixture of two aqueous solutions of acid to get a third solution. So what's basically happening here is we're going to mix two things to get a third. All right, let's get started here. So we have here that we have how many gallons of each of a 20% acid solution and a 70% acid solution should be mixed to get 20 gallons of a 40% acid solution. So basically, we have acid diluted with water. In the first solution, 20% of the content is pure acid and the other 80% is just water. In the second solution, we have 70% is pure acid. This one is stronger, and the other 30% is just water. And we want to mix those together to get a 40% solution. Notice the question is how many gallons each of the 20% acid and the 70% acid solution. So those are my two unknowns. You have to identify the unknowns. So I'm going to just label those. So I'm going to go ahead and let X equal the number of gallons of the 20% solution. So X is the number of gallons of the 20% solution. All right, and Y is the number of gallons of the 70% solution. So those are the two unknowns, the two that are going to be mixed to get the third one, the mixture. So this is the number of gallons of the uh, 70% solution. 70% solution. And what we have here, we're going to mix those together, and the result is going to be 20 gallons of 40% solution. So at the end result is going to be 20 gallons. 20 is the number of gallons of the mixture, which is going to be 40%. 40% solution. So we're mixing the two 20 and 70% to get the 40%. Right off the bat, since I'm only mixing these two acids together to get the third, I see that I have an equation. The relationship between x, y, and 20. Because x plus y has to equal 20 because I'm mixing x gallons of the 20% solution with y gallons of the 70% solution. And in total, I want to have 20 gallons of the 40% solution. So x plus y has to equal 20. Now my next equation, I have two unknowns here, x and y. So I need two equations in order to figure out either one. The next equation is going to involve the amount of pure acid in each solution, okay? I'll start from the bottom here. I'll start with this 20 gallons of 40% solution. So since I want 20 gallons of 40% solution, what that means is that 40% of those 20 gallons will be pure acid. So that the amount of pure acid in gallons is going to be 40% of the number 20, or zero point 0.4 times 20. So that's the number of gallons of pure acid I will have in my mixture. All right. Now, what about this middle solution here, the 70% solution? Well, if it's 70% solution and I have Y gallons of it, then the amount of pure acid is going to be 70% of Y, or zero point 0.7 Y. And to that, I'm going to add the amount of pure acid that comes from the first solution, the 20% solution, which is going to be 20% of X, or 0.2 X. So here I have X gallons of solution plus Y gallons of solution should equal 20. And here I have 0.2 times X gallons of pure acid plus zero point 0.7 times y gallons of pure acid equals zero point 0.4 times 20 gallons of pure acid. Well, I can simplify this second equation a little bit. So this is the first system I encountered. The next system, we still have the first equation, x plus y equals 20. But I can multiply zero point 0.4 times 20 to get, what's that, zero point 0.8. So I'll have 0.2x plus zero point 0.7 y is equal to 8. And there I have my system of equations that I can go ahead and solve to find x and y. All right, well, let's see. We can either use substitution or elimination here. And since the variables are all lined up nicely because both equations are in standard form, I'm just going to use elimination. So I'll call this equation A here. Oops. I'll call this top equation, I'll call that one equation A. And I'll call the bottom equation down here equation B. And I'm going to try to eliminate the variable x here. So I'm going to try to get rid of x. So to get rid of x, what I'm going to do is I'm going to multiply negative zero point 0.2 times equation A and see what that yields and add that to equation B. So here's what my new system is going to look like. Negative zero point 0.2 times equation A is going to be, this is equation A, so it's going to be negative zero point 0.2 x, and then negative zero point 0.2 times y would be negative zero point 0.2 y, and that should equal negative zero point 0.2 times 20, and negative 2.2 times 20 is negative 4. And then the bottom equation is going to remain the same. Equation B will remain the way it is. Equation B, so let's see. Equation B, we have 0.2x minus or plus zero point 0.7y is equal to 8. Now the next step in elimination is to add these two equations together. So I'm going to make a bottom line here. And negative 0.2x plus 0.2x just cancels. But negative 0.2y plus 0.7y gives me 0.5y. And this is equal to negative 4 plus 8 is positive 4. So to find y, I can just divide both sides by zero point 0.5. zero point 0.5. These would cancel out. And it turns out that y is 4 divided by zero point 0.5, which is 8. So remember, y was the number of gallons of the 70% solution. So now I've realized, I see that I have 8 gallons of the 70% solution. All right. And since there are 20 gallons in total, remember x plus y had to equal 20, right? Since there's 20 gallons in total, and I have 8 gallons of 70% solution, that means I must have 12 gallons, 12 gallons of the 20% solution. So this was the value for y, 8 gallons of 70% solution, and this was the value for x. And that is how we approach our mixture problems.